All right, cool. So does anybody have an example graphing problem that's really giving you a lot of trouble, or you just gotta make one up?
Yeah, maybe.
Unable to test.
I lost my page.
That's right. It's in there somewhere still. It's not like the old Mr. Bill from Saturday Night Live. Thankfully, somebody got that. One of my fellow older people in the room. Yeah, a little bit before a lot of you guys. So I am obviously going to ask you specifically what to get here. You should know what you need to find. What do you need to find to be able to graph this? Good. So a good place to start is the easy place. The amplitude here would be 3/4. And I don't really care actually what the hell it is. I could put 18 pi there. And you wouldn't care because you're going to go up to 18 pi and down to negative 18 pi and then fill in your picture. Who cares? So you just got to make sure that you do that. What else can I get? Yeah, what do I have to do before I can get the phase shift? The period I can get directly. What's K? Yeah, K is
2 pi.
2 pi.
1.
So the period is 1. Cool. So we caught up to you. And then what do I have to do before I can figure out the phase shift? What has to change? What has to happen? How do I have to rewrite this? What do I have to do? The phase shift is how much it moves where?
Right.
Left or right. And what variable, of course, controls left and right? X. So I need to see what is affecting X directly. Right now I know that pi over 2 is being subtracted from 2 pi x. Who cares? I need to know how X is being, so I take out 2 pi. That's where this might get a little interesting. The pi cancels. Divide a 2 out. It's already divided by 2, so now it's divided by 4. How are we doing there? So we all should be able to handle that. If you really need to, you could certainly do this. That's what's in there now. What did we take out? 2 pi. A lot of you guys are like, that helps me out a lot. Thanks, Joe. Well, you divide by something, you multiply by the reciprocal, kick ass. There's 1/4, right? Don't make a big deal out of that. When you just take something out, you divide it out. When you divide, you multiply by the reciprocal. None of that is a problem. Don't make it a problem. Already enough problems here already. So what is my phase shift then? Yeah, 1/4 to the right, right? Because it's the opposite of minus. All right, so far, decent enough? Okay, now here is the trick. Right? A sine, cosine, how would you say it normally looks? From 0 to what? Or normal cosine? And we know it goes forever, but I'm just focusing on the, like what I call the primary cycle, the little snippet that I use to move around. That's going to be from 0 to 2 pi. That represents the period. And cosine starts where? Yeah, it's going to start maximum. If I cut this in half, cut that in half. And then what's it do from here? Here it goes to, what's it do with pi over 2? Cross, okay, that's a root, right? Goes to 0 there. At pi, it's going to be -1. And then it goes back to 0, and then it goes back to 1. Not a v, but we know it makes this little.
do you know this?
Yeah, how do you know?
Yeah, like, what did we
Because
get?
I'm smart. No. I'm not answering the question. Think about these are the values that you definitely should already know.
Like,
Right? So what I'm telling you now is that what I've been doing is so far, and what I might not have made the biggest point of to get across, but I definitely said it at least once. These are your major points that you want to graph. Because they're all things that I already know, and then I can just shift them around as I need to. Right? So I want to kind of show you how, if you know these, and of course, how do I know them? Well, what is cosine of pi? You better know that. Now let me warn you this right now. Here's another little thing since you guys are here. Since you guys are here, there will be two parts to this test. The first part, there will be no calculators allowed. Aw. No smartphones. No technology of any kind. So you can imagine what I'm going to ask you. I'm not going to ask you, I could if I wanted to, but I'm not going to ask you long divide 17 into 4 and 9. So I'm going to ask you what's cosine of pi over 6. I'm going to ask you what's secant of 225. Those kind of things. So that I know for sure that they're really coming from your memory instead of somewhere else. Cool. All right. So is everybody decent with this? Is that? And of course, the corresponding thing for sine would look like what? Sine starts where? 0. Cut it in half again, and then in the middle of those two. It starts at 0, goes up, 0, down, up. And it goes forever in both directions. But don't forget the little arrow at the ends. But you just want to capture that primary cycle. And then we can move that around if we need to. Okay. So knowing this, if I know where it starts and where it ends, wherever the hell that is, I can cut that in half, cut it in half again, and then just fit this picture in. That's it. That's all there is to it. Period.
Oh.
I like that sound.
Yeah, I totally get it.
So what is the phase shift here? 1/4. So it's going to start at 1/4. Now how far from there do I want to go to get to the end? 2 pi normally, but for this problem, the period is 1. No pi's involved. The pi's canceled out, didn't they? Poor little things, so they're gone. So I want to go from 1/4, well, let me draw on over that thing, up to plus 1 is
1 1/4.
I like 5, which is fine. 1 1/4 is fine, but it's easier to work with improper fractions. Now, what's right in the middle of those? 1 something and 5 something was right in the middle of 1 and 5. 3. So 3/4 right in the middle. And then what's right in the middle of those? That's nice. That's beautiful. So 2/4, so 1/2. 3/4, 4/4, so 1. How are we doing so far? You guys see how I got those? Now you can have the little method I showed to show you how to get the beginning and the end.
How do you get to the beginning? How do you get to the beginning again?
Because I know for sine and cosine, I've set it up so that I always start at 0. If I know the phase shift, I now know where I should start. Now, I want you, of course, behind all of that is this goes on infinitely long in both directions, so beginning and end is kind of weird. But we can break it up in these cycle pieces. So the representative cycle starts at 0 normally, ends at 2 pi normally. Now I know it starts at 1/4, because it's been shifted by 1/4, and it ends 1 later at 5/4, the representative cycle. I know it's a cosine. Yes, ma'am?
No, I was just
I like it. So it's a cosine. What should I put here and there?
1, -1.
3/4.
3/4.
Negative 3/4.
Why? Because you go back here.
Yep.
So this is where you start. This is how far from there you go. And this is what to put on the y-axis. That's your amplitude, yeah. Okay, cool. Okay.
Awesome.
You start.
So now where does cosine start? Yeah, so wherever I start, it starts at the maximum. If this would have been a negative 3/4, of course, I would have flipped it over, but that's not a big deal. I've already got my important points. These points are not all roots. A few of them are roots. The other ones are maximums and minimums, right? So here's a max. The next thing it does is goes through, minimum, through, maximum. Then you draw in. You put little arrows at the end so you make me happy. Sweet. Okay.
So now how do you know the points that there we know it, but here we don't know.
Okay.
We don't know those specific points directly, but I know what these trig functions do. I know over a period, it does certain things a quarter of the way through, 2/4 of the way through, 3/4 of the way through, and that's all I need to know then. If I know the beginning and end, I cut them into quarters, and I know what it does at each of those positions. So how do you check this?
Yeah.
Calculate.
How do you always check something once you have the graph?
Calculate.
I like it, but not even. I don't entirely like it. Just take 1. If you plug a 1 into that equation, what should be the output? 0. You can see it. It's supposed to be 0. So you do it and you see it. And you do a second one, and if 2 of them work, you feel really damn good about it. Yeah.
Okay, so for the period, K is always going to be what's before the X.
Yes, so it's
And
almost
the
like
original-
slope in a way, if you want to like
The
F.
original period is always going to be on the top.
Yes.
Okay.
I was afraid you're going to say always 2 pi, but it's 2 pi for what 4 trig functions? What 4 trig functions have 2 pi period? Sine, cosine, and of course it has to be secant, cosecant, because those are related. And of course tangent and cotangent have pi. It's very emphatic pi. So tangent negative pi over 2 to pi over 2. Cotangent 0 to pi.
Wait, can you repeat that?
So, of course, here the secant would be like this, right? For example, blah, blah, blah. And the cosecant, same kind of idea. So the tangent, and this is all on that sheet I gave you a while back anyway, was this idea, right? Cubish. And the cotangent is just the reverse of that. Which only goes through.
Can you do one of them? Tangent or cosine? Can you do one of them like same like this?
Do a tangent?
Yeah.
Shifting? Yeah, sure. Is everybody cool with that? Okay. Okay. So what I'm saying there also is, can I take that away? So we got that? Everybody else? Okay. So what if we had now, with tangent, there's really no amplitude to talk about because it goes to infinity and negative infinity. But that would kind of help us. There are some anchor points I could put on there that I'll do when I graph this. But I can talk about the period. What's the period of this going to be?
6 pi x over 1. 6 pi?
So it's going to be, what is the old period? What's the period of tangent in the first place?
Pi.
Pi. Divided by
1/3.
1/3. Which is
3 pi. 3 pi.
cool. And how do I get the phase shift? Take that 1/3 out just like last time, right? So it'll be x plus 1/2. So just shift by 1/2 to the left. Okay. Now here's a really good place. Tangent and cotangent. Well, cotangent is easier. Sine and cosine are relatively easy because they start at 0. That's kind of like where we break it up for our cycle. Tangent and cotangent. Well, tangent especially is kind of weird because it starts at negative pi over 2. Right?
Yes.
Yes, thank you. So if I take this and say 1/3 x plus 1/6, I don't know if you guys remember, this is the way that I showed you how to figure out where it begins and ends. this is a good place to do that because the beginning and ending is not 0 now, it's something else. So the shift is a little bit harder to get at.
Why is equal negative 2 pi?
Say again?
Why is negative 2 pi?
Why is it negative what? Oh, here?
Yeah.
Why is it negative pi over 2? Because what does it normally start at? Negative pi over 2. So it normally starts at negative pi over 2. Now I want to see where it actually begins now. Right? Okay? Trying to think if I make this a little easier on us. Probably not. Actually, I could. I don't want to make this. Let me catch you up with my brain, with what I'm thinking. This would be kind of a gross shift because we have pi period, and I'm shifting it by a non-pi number. And I don't want to do that to us. Tangents are already kind of hard enough. So, not even asking your permission, I'm just going to go do that. And now this will be pi over 2, and that's a little bit easier. You guys with me? So the last one I was able to make it all numbers. It started at 1/4, the period was a non-pi number. I don't want to try to find where 3 pi minus 1/2 is. Right? I really don't. If I don't, you guys probably really don't. So now I've got this. I want to see, normally it starts here. Now I want to see what the input has to be to make it the same as that would have been, to see where it moves to. Yeah?
Doesn't the phase shift change when you take out 1/3?
Yeah, so now this is, sorry, so pi over 2. Thank you. So let's see how to work this out. 1/3 x equals, subtract the pi over 6. So it's negative pi over 2 minus pi over 6. Negative 3 pi over 6 minus pi over 6 is negative 4 pi over 6. And then multiply by 3. So I get negative 4 pi over 2, which is negative 2 pi. So now I know I'm going to start at negative 2 pi. What's the period? 3 pi. So where am I going to end?
1 pi.
Good, I like it. And what's at those beginnings and endings for tangent? Asymptotes. I love it. Cool. So now, really, the only important point in here truly is the middle, because that's where it's going to go through the x-axis, right? So here, the middle's easy enough. At 0. There, it's easy enough. What's in between negative 2 pi and pi? Yeah, negative pi over 2. So really, with tangent, you could be a little more precise. But this is fine. I know it's going to be cubish. I know it hasn't been flipped at all. What the, I don't know if I want to ever look at it. What the doubling does, normally at pi over 4 and negative pi over 4, who remembers tangent of pi over 4? What's special about that? That's where sine and cosine are equal, so tangent would be 1. So now, 1/4 of the way in, it's going to be negative 2 instead of negative 1. If you guys are with me. So the anchor points for tangent are a little bit strange. There's really only 3 of them. There's the asymptotes at the ends and the 0 right in the middle. But you can consider that pi over 4 normally would be 1 and negative 1. So that's really the only effect that a multiplier would have, is if it would raise or lower those. It would make the tangent stretch up a little bit or squish it down a little bit. I don't think I would be requesting that much precision. So like here it would be negative 2 there, and pi over 4 away from here. Oh, let me think. Should be pi over 4 away from pi. Well, now it's 1/4 of the way. I don't want to go all that precisely. So somewhere right there. So it's going to be negative 2 and 2. But the main thing is the shape. Of course, I didn't give myself enough room there, but that cubish shape to get in there. Now, I will tell you this. if I do give you a tangent shifting around, I'll probably give you the original shape to work with. So what I'm really saying right now is I will probably give you a couple of sine, cosine problems to shift. You kind of with me? And they will probably have all of the shifts in them. Okay. So in the homework, it kind of steps you up in parts. There's no phase shift at first. Right, so they're really focusing on what does K do, what does the amplitude shift do, and then they bring in phase shift. But this would be an exact problem I could give you on the test, just like this, in terms of sine or cosine. Right, with all these shifts going around. Yeah.
So, if we do only the steps without, like,
So if you give me this,
yeah, how does it?
but don't give me any graph,
Yeah.
it'll be a little over half points gone. Because the main thing here is, do you know the basic shape, and do you know how to take this and create a visual out of it? That's the main thrust of the problem. So you're going to lose over half the points. Yeah.
Is those two the pi halves, this is the x plus pi halves?
Yeah, it's another way to think of it. Where does this become 0? At negative pi over 2. So it should do the same thing this did at 0 at negative pi over 2. It does. Cool. I like it.
So always in the beginning we use pi over 2, negative pi over 2, right there.
For a tangent. Yeah. Because tangent, the primary cycle is from negative pi over 2 to pi over 2.
Well,
Just because.
So, pi, the asymptotes are always the same too? The
For
negative
a
two
basic
goes-
tangent, it's going to be negative pi over 2 to pi over 2. Once you move it around or change the period, those are, of course, going to move around.
Oh, okay,
Yeah.
so they're not definitely that.
But if you find where it begins and ends, that's where the asymptotes go. The thing is, I'm really curious if anybody just heard what I said earlier. You're only going to get sine and cosine graphs on the test. Did anybody pick up on that?
Okay, six, but
I might give you kind of an uglier tangent one for a bonus, maybe, but.
Because that's what you said, but if, so I want to make sure.
Oh, what do you mean?
Forget about this.
That is.
Never learned this.
Yeah.
I have problems whenever you have the amplitude where you have to add more to it, you have to go more up, more down.
Oh, yeah. That's the very last thing I would do. So if there was a +2 here, I would get that, and then just every point like that would go up 2. Right, and basically, and then I would take that up 2, and then that's the very last thing I would do. Don't even think about it. Don't even treat it like it's there until the very end. So the problem we did earlier, that was here with cosine. If there was a -3 there, I just take my whole picture, every point, 1, 2, 3, 1, 2, 3, and then just fill it in. The last thing I would do.
And it doesn't matter if it's on the beginning or the end of it.
Oh,
If it goes like a 2
plus
minus
2, doesn't matter.
What if it's on the other side? Is it like after the whole phase shift and then -2?
Doesn't matter. As long as it's outside of here, it's an up and down. And I do up and downs at the end. Because what am I going to go up or down? I'm going to take this up or down, so I have to know what the hell that is first before I can move it up and down.
It starts at negative pi over 2, I get that, but if it shifts to the left pi over 2, why is it 2 pi? Or like negative 2 pi? I feel like it should just be negative pi. If it's 2 halves, it's just 1. Yeah,
Did that work out?
like I don't get what you
3
did with
pi over
the
6,
formula
4
there.
pi over 6, 2 pi over 3, 2 pi, that's right. Oh, okay.
That'd be a
It seems
sense
too much
of
like
what
sine
I
and
have.
cosine. The weird thing is, all right, real quick, tangent x is that, negative pi over 2 to pi over 2. If I do tangent 1/2 x, what's the period now? What was the period? Pi divided by 1/2 is 2 pi. Now, here's the weird thing. Sine and cosine, again, They're easier because they start at 0. So if I double all the inputs or something, then 0 stays at 0. But here, these are on either side of 0, so both of them have to shift around to make 2 pi fit in. So this would go to negative pi, and that would go to pi. Every single input would now become double what it used to be. So it's a really good question, and it's something that I don't think I've ever really thought directly about, because I just always kind of do this. Right? But that's what happens. It just shifts both of them out to make room for the period. The reason sine and cosine are so much easier is because one of them is 0. It's never going to go anywhere. Double it, 0. Cut in half, 0.
I don't
Right?
get it, the period was 3.
No, so this example, just to really get at what he's asking. There's too much other crap going on there.
I know, that was me. Why are you doing that for?
Right?
Why are you doing this for?
You asked me to. That's the main reason why. Okay.
One more question.
Yeah.
So if that's true, instead of doing your way, because I have no idea where you got the 1/3 x plus pi over 6. Oh, yeah, there is. But anyway, could you just double like whatever you would initially think the
Yeah, so I mean, there's a whole other way to do this.
Yeah.
The period is 3 pi. And it gets a little weird, so normally the period is pi. So now if it's 3 pi, it would have to go down 1.5 pi and up 1.5 pi. And then if you shift it back, that negative 1.5 pi is now negative 2 pi. So that matches up. So that's a whole other way you could approach this. You're right.
Oh, a period is.
And see, this is where you get to the point in mathematics where sometimes I've got to make a choice to not give too many ways to do something because that might confuse a lot of people. But then you have to kind of make math your own. Say, I think I got a better way to do this than what he said. And it's better because it makes more sense to you. It's not better because it's better, it's just another way to do it. I actually can't remember the way I did it when I first learned pre-calc. It's a long time ago. But now I'm so used to doing this from teaching it this way. Yeah. Do you understand the other way to do it? So you can certainly do it that way. Tangent's freaky again because it's got to go both
Can you
ways.
just sign since we're having a
Yeah, sure. We'll do one more with sine, and then we'll move on to another topic.
Are we gonna have to ask problems and all that?
Now, what I heard, what did you say?
Triangles.
Uh,
Ask.
oh, all right. I said ask puddles. I'm like, when did I, what is that? And when did I discuss this? What do you think?
Yeah.
Yeah.
Ah. Okay. Sine. Oh, I don't want to be too evil, do I? That's fine. All right, just load this thing down with pi. Run it pi. So again, like I said earlier, the one curveball I threw at you on this is not even that big of a curveball. What's the amplitude? And again, we don't care. I'm just going to put pi, negative pi. Who cares? I can put square root of 28.7. Who cares? What's the period? So you're going to sine now again. So it's 2 pi over what?
2/3.
Over pi over 3. Which is 2 pi times 3 over pi. Right?
Yep.
Which is 6. Cool. You doing okay so far? Yep. Mixing it up. That's right. You know I'm going to do that on the test. Phase shift. Again, I take this thing and I take out the coefficient of x. So what am I left with in there? 1/2. 1/2. 11. So what's the phase shift? 1/2 to the left. And 1/2 to the left. Sweet. Okay. All right. Now, where's it going to start? Normally starts at 0. Phase shift took us back by a half, so it's going to start at negative 1/2. And the period is 6, so where am I going to end? 5.5, which is also known as
5.5.
no, 11.5. All right, and now you just start breaking this thing up. Right, this is the important part now. You fit the period in there from the beginning to the end. If you can just break this up into the parts, the 4 parts, you can then just fit the picture right on top. So what's right in the middle of these two? 5 halves. I like it. So 5 halves. What was that? Does that look like it's in the middle? Sure. And then what's right in the middle of these two?
2.
I like it. So let me make sure everybody knows how to find the middle of things.
2.
How do I find the middle of any two numbers?
1.
Divide by half.
It's not a good procedure. That's the answer is 1, I know. You add them and divide by 2. You take the average, right?
Yeah.
So negative 1/2 plus 11/2 is 10/2, which is 5. Cut in half, that's 5 halves. So you take the average of the two numbers to find the middle. Take the average of these two numbers to find the middle. Negative 1/2 plus 5 halves is 4 halves is 2. Cut in half is 2. Listen to you.
Yeah.
Like just messing with me. And then right in the middle of there,
8.
8 divided by 4.
4.
So this is 16 halves, which is 8. Cut in half is. How do you get 11.5? How do I get? So I know I start here. Is that cool? Because I move half to the left, and I normally start at 0, so now I start at negative 1/2. The period is 6, so I have to go 6 up from here. Well, negative 1/2 plus 6 is 11 halves. So it's just because now that'll fit in the period. Cool. So now I just throw on top of these points the picture, the image that I know should be true. It's a sine, it's not been negated. I should have probably made it negative, and that would have just made it do this first. But now it starts here. Where does it reach its maximum? Right at 1, and what's that maximum going to be? 5. So it reaches maximum here, goes back to 0, minimum here, back to 0. You can see no matter what the phase shift and the period changing makes these numbers become, the sign doesn't care. It's periodic. It has to show that same image over and over, so I'm guaranteed it's going to look like that in there. The only thing you have to be careful about is if it's negative, it's going to do that first, yeah. Just have to flip it because it's negated. Here it wasn't, so now I can just fit that in. That scale's a little freaky, but I don't care. Is that better? Yeah.
I remember seeing a problem that was like the period wasn't negative. That just makes the whole entire thing upside down. Right?
So here's the thing to do. If I had sine negative 4x, what is in general sine of negative x equals, how did sine work? Is sine even or odd?
Odd.
What's it cosine?
Even. Not even or cubish.
So that would be negative sine x. So the period can never be negative. That's a little freaky. Start here and go inside yourself. I don't know what that means. What does negative mean? A period is supposed to be a length or something that something fits into. A negative length freaks me out. So what we do is we first rewrite this as this. Now I know it's a sign that's been flipped with a period of what?
4.
I know I'm pointing to the number 4, but
1/2 pi.
the old period's 2 pi divided by k. So exactly right. Half pi or pi over 2. So you take that negative out. Now if I had cosine of negative 4x, cosine must be the other kind of function that doesn't care when you put a negative in. And I really want you guys to realize, this is what I keep in my head when I think about sine and negative or cosine negative. If I'm at, how do I want to say this? You can do it, Jeff. if I'm at 30 degrees, and I want to compare that to negative 30 degrees, which one changes, the sine or the cosine? Yeah, the sine, the y, becomes negative. What's the cosine do? It's the same thing. Now the y is the same value, it's just the negative values. That's why this is true. Because of this picture. If you're at an angle and you look at the negative angle, that's how I remember which one's odd, which one's even. X is going to say X doesn't care. Y is going to change. Okay. Where you got this here? Okay. So what's the next thing we want to look at? No more trig graphs.
Do from 39 from 6.5.
All right. Oh, and let me tell you this. Everything we've done must be memorized. So no formulas will be given to you. You should know the law of sines, the law of cosines, right? And you should also know the what I gave you on this little thing here. Oh yeah, I am so evil. The sum and difference identities. Oh yeah. So let's do this one first, and then we'll do some of those. After all that, I forgot which one it was. Which problem was it?
30.
Third. This one here. Right? This is 12. This little dude here. 5. So they say to find this. This is what I want to know.
Yes.
Okay, cool. Now, the first thing you notice, and this should not be a surprise considering what section we're in, but if you solve this on a test, how many right triangles are there? None. Okay, shit. Gotta let go of that possibility. Can't really use Pythagorean anywhere in here. Can't use trig functions directly. I can use law, so that's why it's in this section. This is a law of sines section, so that must mean I have what I need, but what do I see here if I didn't know it was law of sines, of course?
Side and a corresponding angle.
Yeah, I have the angle here and the side across from it, right?
Yeah.
Now, the whole problem with this problem then is what path am I going to take to get here? I have its angle there, right? So if I just had another angle in there, maybe, or if I just, like if I had this angle, couldn't I set up a ratio there and then that ratio with the unknown?
Yeah.
All right, so that's one possibility. So you have to kind of start figuring out what path do I take? Where do I, obviously I'm going to have to do something with that triangle maybe, and that one, or maybe this big ass triangle here, right? Maybe. Do you see you have 3 triangles to play with?
Yeah.
You have that one, this side, that one, this side, and then the whole thing. Cool.
Is it 12? X 12? The answer 12?
Oh, I don't know yet, but I did forget that they gave us this side here,
Uh-huh.
which is very useful.
No, it's different.
Yeah. So what is really nice about, now that's one side they gave us. Let me put in purple everything they gave us. What kind of triangle is this little dude here?
Equalize.
I like it, but no. I know it's not equilateral because the angles won't be equal at the end. Come on now, what's this triangle that has 2 sides are the same? Isosceles. And if that side is the same as that side, that angle and that angle have to also be the same, right? So then I know that that's 25 degrees. So let me back up a step here. You almost never see isosceles triangles in a problem, and that's probably why my brain blocked out that other 12. But when you see that, you're like, oh, sweet, because now you know the other angle. If they give you one base angle, you know the other base angle. They're equal.
And there you know the third angle as well.
Say again?
You know the third angle as well, 130.
Yeah, so now you know this one. Good. That's the next step. So that one, yeah. So it's 50, that's 130.
Did you know the other one's 50?
You know this angle here has to be 50 because that's one continuous line, so it makes a 180-degree straight angle.
Can you give us a problem like this one?
130.
Like this one, yes.
Like with similar.
I know what you're shooting for, but let go of that.
We're like faking.
What's that?
We're faking right now.
Maybe I saw
You
something.
know
That
some
might be
rich
right. No, we're not done with this problem yet. I mean, we're filling in a lot of crap, but have we gotten to the point where we can get there? What's? So let me interpret what you're saying. Angle A is 105 degrees.
Yeah.
You aren't all just suddenly yelling out random numbers.
The price is right.
All right, so now, yeah, now I can do it. Now I've got this side, this angle. I've got this angle, and the only unknown I would have in that proportion would be that side. So what is it exactly I can set up?
Cosine 105.
Sine of 105 over 12 equals sine 25 over x.
Can we do it cosine, right?
The only reason you could not use cosine is because this is too early. This is section 6.5. You officially don't know law of cosines in this section. And the further you get along in math, the harder it is to keep track of what you know and what you don't know yet. When you go back to finish homework, trust me, I know all too well. You do a problem and the teacher says, no, it's not. No, you don't know that yet when you're in that section. So in this one, do not use law of cosines anywhere in 6.5 because you don't officially know it for section 6.5 yet. You know that in 6.6. So be careful. That's why actually I prefer test. If I gave you that problem, you could do it any way that comes to mind. If law of cosines is easier, hell yeah, I'm going to use that. So whatever you get there, I don't know. We can all solve this now. Okay.
What if they had introduced that other 12?
That would have been more interesting to me, but I don't know if I want to get into that. It might not be enough information to do it, but it sounded more interesting. This was too much to use. Made it a lot easier than I thought. I'm the only one here that would be upset about that. I promise to. Huh? Yeah, then obviously, well, again, I don't know if I want to get into it because I don't know going in if that's enough for the problem to be done. That would be more like just feeling it out and then seeing, oh, it can't even be done. That would be a little frustrating. Yeah.
Can you do cosine of the minus one?
Oh, before I forget, thank you for doing that. So in section 7.2, I'll tell you this. Section 7.2, homework not due by the date of the test. If I were you, I would do a few, because I will hold you to the addition, subtraction formulas. What I won't hold you to is the one for tangent. The addition formula for tangent.
The one.
Yeah. But I can do a problem like that. I can show you what the idea is behind that problem. And actually, we can do that one exactly.
So for what section is this?
This is. Oh, and there was a little discussion about chapter 4, but I'm not going to have that last section in 4. This is only going to be about the trig, so it's 5.1 through 7.2. So 7.2 homework not officially due, but you should do a few of them to get used to that addition subtraction formula. But you have a little bit of time to finish that out. So this is the formula for the difference of angles for the tangent. So it's a lot like the one we did last time, the alpha and the beta. You could do similar things to prove this formula here. But for this problem that you're asking about, it says what's the tangent of the inverse sine of 3/4 minus inverse cosine of 1/3.
That's what we heard about too.
This is 2.7 and 7.0.
Yes, 7.2.
I don't even know what it's doing.
What's the problem? So again, this is the one I'm not going to hold you to know, but I'm going to show you how to do this problem because it has to do with problems you're going to have to be able to do on this test. So in one of the sections they talk about how to do a problem like tangent of inverse sine of 3/4. So let me do the first step here, and then we're going to focus on how to just do that piece of this problem. If I know this is the rule, the tangent of the difference of things is this. How would I rewrite this? What's S here? Sine. That's kind of nice, SS. So here, this is the tangent of this minus the tangent of the other dude all over 1 plus the tangent of the sine, tangent of the cosine. I'm not cosine, yeah, cosine. Okay, so that's just using the rule to rewrite the problem. Not a big deal there. So if I know the rule, I can just throw the right stuff in the right place. The important part about this problem then is, can you do any of the little pieces to it? If you can't, then you're screwed. So what in the hell? Let's just look at this one little piece. Now, if it was this, if it was sine of inverse sine of 3/4,
They cancel out.
now of course it isn't. This is more evil than that. But what does this really represent? What is the output of an inverse sine?
An angle.
An angle, I love it, because the input of a sine is an angle, so the output of an inverse sine is an angle. They have to go together. You with me? So this is the angle whose sine would be 3/4. So can't you draw a little representative triangle for that? And then it can give me any freaking trig function I ask for. So what I really want you guys to realize, this is an angle. The same way that the log of 7 is a power. The power I don't know yet. The angle I don't know yet. Right? So what would happen if I did this, if I applied sine to both sides? Just kind of play with this for a second. Don't I get 3/4 equals sine theta? Doesn't that describe a triangle? What about this triangle do I know?
It's like, you know that it's
3, 4, 5.
and then
Be careful. That's 3. What's 4? Yeah. It's a little bit evil. It's not 3, 4, 5.
Root 5, 2, 3, 4, root 7. 2, 3, 4.
No, it's not. It's
Root 7.
something a little bit uglier than that, right? Because square root of 16 minus 9 is square root of
5.
It's 7.
I love you guys. Sometimes I really think you're just yelling out random things, hoping something will catch.
We are.
2.8 pi. That's right. Whoa. All right. I don't mean to mess with you, but I have to.
It's 3 hours of standing.
So real quick. Anytime I see something like, if I saw a secant inverse of 4/7, that actually represents a triangle by itself, where what's true about it? The secant's related to cosine, right? So it's 1 over cosine. So this would be, that would be 4, that would be 7. Right? This is like the opposite, the reciprocal ratio. So not 7 over 4, 7. And then, so that by itself sets this triangle up. And then I can ask you out here, I can ask you for any other trig value of it, and you just have to figure out the last side and make the right ratio.
Hold on. So you secant is related to cosine? And, oh, but it would go inverse again.
just to make sure you put the numbers in the right size, right? However you have it memorized. I always have to think about that's cosine, so it's got to go on the x side and the hypotenuse. With me? Yeah.
So cosine's not 7 over 4, it's 4 over 7?
Well, if the secant is 4 sevenths, then actually the cosine, I'm sorry, 7 fourths, I'm thinking ahead, would be 4 sevenths. Right?
But you put 4 7.
If cosine, no, of course I did. If cosine is x over h, then secant is h over x. 7 over 4. Why did I do that?
Yeah,
that's what we're talking
that's
about.
what I'm-
Oh, I'm thinking about it.
Yeah.
My brain is going the other way. So this is meant to be 7 over 4, my bad. I wrote that in my head, I'm thinking 7 over 4, and actually I have 4 over 7 over 4, so forgive me. Real quick, why would that never work the way that I ended up writing it? I love my brain. Secants can't be any less than 1, or, it can't be in between -1 and 1, right? You know that from the picture. So I certainly couldn't have that output be less than 1, so I meant 7 over 4, it's fine. The bigger idea is the fact that any inverse trig expression sets up a triangle using the ratio that you know. This is the angle whose secant would be 7 over 4. That's why that's like that. And then whatever other trig function I ask you, you just figure out the last side and answer that question. So here, that sets up that triangle. They're asking me for a tangent of that, so what would that be?
3 over 7.
3 over root 7, which is 3 root 7 over 7. So that piece is 3 root 7 over 7. Minus, and then you would keep going. So what triangles? Go ahead.
So that means the angle whose sine would be. Is that what that says? The angle whose sine would be.
Yeah, because look what this says. What's the sine of theta in this triangle? What is the sine of theta? 3 over 4. So the angle is the inverse sine of 3/4. Isn't that exactly what that says?
Why is the angle the inverse sine of 3/4?
How do I solve this for theta? What do I do to both
Okay,
sides?
okay.
Take the inverse sine.
Got it.
So now theta is the inverse sine of 3/4. So that's how I know when I see inverse sine of 3/4, that represents the angle whose sine would be 3/4. I can set up the triangle then and answer any other questions they want me to. So here, what triangle could I set up? What's happening here? Cosine. I like it. So what's 1? The base is 1. And 3 is the hypotenuse. So this side would be good. Square root of 8, which is 2 root 2. Right? Square root of 9 minus 1, 8. Square root of 8 is 2 root 2. We simplify that. And now what's the tangent of that?
2 root 2.
2 root 2. Y over x, right? Okay. Over 1 plus, well, we already figured out this. We did that up here, right? So that's 3 root 7 over 7. We already did this, that's here. That's 2 root 2. And then I just got to throw this whole big mess, maybe in my calculator to figure out what the hell that is. So to back up a step, a definite problem you're going to see from me would be a straightforward one like this. That's of course another evil one. You got to be careful about seeing certain numbers and assuming they fit into certain other numbers. This one won't. So it's not a 3, 4, 5 triangle, is what I'm trying to say, right? You gotta be careful about seeing those 4 and 5s and thinking certain things will happen. What triangles is this set up here?
The y is 5 and x is 4.
Yeah, cotangent's gonna be x over y. I like it. So the y is 5, the x is 4. So what's this here?
Root 41.
Yeah, root 41, right? 25 plus 16. And now, what's the secant of that angle that this sets up?
Root 41 over 4.
Secant is like cosine. The cosine is the x piece. It's going to be 4, root 41 over 4. That's the 1 over the cosine. Maybe, yeah. Where's tangent coming in? Sorry. You could. You actually could. You could realize that this describes the same angle as this. But then that's y over x, so y over x. Either way you look at it, they end up in the same place. Of course they do, right? They all have to reference the same triangle. The triangle can't change, just the ratio that I make of the sides changes. Right? So it's still going to be 5 here and 4 there. But you can certainly do that if it's easier to get the ratio set up. Okay. So if you haven't seen something like that in the homework yet, then I know where you are in the homework, or where you are not. Well, are you guys? I don't know if you guys have done any law of cosines yet. That's going all right. Has anybody hit the law of sines with the 2 cases? Is that going okay? Yeah. Not yet. Okay.
Well,
That's
weird
fine.
question, like, I noticed, like, again, in my solution video, like, in the book it says, like, cosine b equals, like, a squared minus plus b squared equals, or minus c squared, but sometimes it does it as all negatives on top, divided by 2ac